Welcome to LNP Renewable System Integrator. Today we are going to discuss about valve actuators. Okay, so for the operation of a valve, manually we were opening valves. Okay, but if it is a big valve or a small valve, it is easy to open it manually. But when it is come to a plant like chiller water plant, heat ventilation air conditioning plants, so there, in order to open this chill waters valves, they might be located at some remote locations, so it will be difficult for some person to go and open it manually. In such places, in order to open the valve, we are taking the application of this valve actuators. So what is the advantage of this valve actuators? So with the help of this valve actuator, we can able to open and close the valves. So what are the topics that we are going to discuss today? So first, what is a valve actuator? Okay, where can I see these valve actuators? Where can I use these valve actuators? Okay, how the actuator looks like? Okay, how a valve actuator works? How a valve actuator is wired? And what are the things as a BMS or a BACS engineer I should know in the valve actuator? So first, as I told earlier, electrical valve actuator is used to control the opening and closing of the valves. It is used in most of the places where the rotatory motion, there we want to make a control. Even for the butterfly valves, we can use the valve actuators. So mostly it is used in heat ventilation air conditioning system, and even for plants also, wherever the water supply is there, oil and gas supply is there, wherever the valves are coming, in those places we can use these valve actuators. Okay. So mostly you can see in a building where the building automation system is already established, or you can see in a building or a mall or a metro station where the heat ventilation air conditioning system is present. For the supplying of this chill waters and taking out of this hot water, we need a supply line, and we have the valves at different locations. So to control those valves, we are using this valve actuators. Even for the pump applications also we can use this valve actuator. See here, this is an example of a domestic water pump. We have a 3 pump, primary, secondary, 2 secondary pumps. So in all these valves, in the opening side as well as on the supply side as well as incoming side and outgoing side, we have the valves. So it might be fixed like this. These valves looks like this. This is an example. Okay. For valve actuator, as I told earlier, this valve actuator is also 2 types. One is normal fully opening and fully closing types. Like a relay, it will be working. So when the supply is given, it will open. Okay, and when the supply is removed, it will close back to its normal position. It means like a spring operation. Okay, so when we give it the supply, when the relay is on, it will open. Okay, when we release the supply, it will return back to its closed position. Same like a normal relay, it will be working. And the other type is that the modulating type, where we use 4 to 20 milliamps. Okay, 4 to 20 milliamps current. Okay, using that we are giving a current as a input, that is 4 to 20 milliamps, and we are taking the feedback current, that is 4 to 20 milliamps. Say for example, if you want to make a valve actuator close, it is already open, you are giving a 4 milliamp supply, what will happen? Immediately the valve will close. Okay, and if you are giving if you want to make it fully open, or if you want to make it at in between, maybe you can give 12 milliamps supply, so that it will open only 50%. If you want to open it 100%, you can give 20 milliamp supply, so that it will open. So it's like modulating type. So modulating type is used in the places where precision is very much important, because as I told earlier, for all the chill water plants, oil and gas industries, based on our applications, we need to control the valves. Okay, so how it looks like. See here, this is an example of a chill water actuator, which is mostly used in variable air volume units and fan coil units. See here, this is the valve, and the valve actuator is installed above it. So with the help of this, we can able to operate these valves. Okay, and even see, diagonal type is also there. This is also a chill water. So there are so many types. So based on the type of valve that you are going to choose, we are going to install the required type of valve actuator for that particular model. See here, for this model we are going for this BELIMO actuator. For this model we can use the SIEMENS actuator. If it is a vertical diagonal type, you can use this valve actuators also. See here, this is for the opening these butterfly valves also, we can use the valve actuators. So as I told earlier, so this will also have the four important things. One is the supply, power supply. It can be a 24 volt supply, or it can be a 110 volt DC or 240 volt. So based on our application availability, what actuator we are going to plan, so the supply is going to differ. Okay. Now for the bigger applications, maybe for it needs more power supply. So in such places, for the bigger, in order to operate the big valves, maybe we need to use the valve actuator of higher ratings. In such places, the voltage supply will also be more. For the small applications like FCUs, okay, in the chill water line, if you want to operate the valves, we can use these small valve actuators. Okay. So in this also we have a control as well as a feedback. Okay. Control normally we used to give 4 to 20 milliamps, and the feedback we used to take from the U terminals. Okay. See here, G0 will be the line and the 24 volt supply. Okay. And this Y2 and Y1 will be like a relay operation. Okay. If you give the supply on the Y2 line, so it will do one operation. If you give supply on Y1, it will do one operation. Like a relay, it will operate. Okay. See here, Y2 retracts the actuator shaft, whereas Y1 extends the actuator shaft. It means if it is extending, if Y1 is extending, this Y2 makes the actuator to retracts. So this is the basic function. This is how basically the valve actuator is getting wired. Okay. So see, this is a simple application of a valve, ball valve, how it is operating. So instead of operating it manually, fix the actuator at the top, we can able to operate these valves by ourselves through automation. Okay, by programming in the DDC controllers or in the PLCs, we can able to control this one. Okay, so this is entirely is going to be an analog operation. Okay, analog input and output operation. Okay. See here, this is an example of a fan coil unit. See here, so this is a modulating valve. So it will operate. It might be 4 to 20 milliamps electrical signal. So we had scaled it to 0 to 100%. Okay, so now it is in the closed position. That's why we are getting a 0%. When it is operating, when there is a requirement in order to establish a cooling inside it, the valve has to open in the return line. So then only we can control the flow of chill water inside this cooling coil. So the air which is passing through this cooling coil will get cooled, and it will the cool air will go into the required place where we want to attain at a particular temperature based on the set point. See here, as I told earlier, if you are going for a DDC controllers, for a modulating valve, an analog output we have to provide from the DDC. So it is going to be an input. Okay, the control, the output command that we are going to give from the DDC is going to be an analog input to the modulating valve. Okay, and also in the same way we will get the feedback also, whether the valve is open fully or not, whether it obeyed our command or not. All these things we will see. See here, this is an example of a pneumatic valve, how it is operating. See here, now it is a 20 volt, it is fully open. If you have 4 volt, it is closed. And see the one more example. See here, the current supply is here. Okay, so when you are giving 20, it is opening, and when we make it to 4 milliamps, what will happen? It is 0, so it will close fully. So this is how gradually, a control valve works. So when the current input is full, 20 milliamps, it will open 100%, and if it is 4, it will be in the closed position. If it is any value which is between this 4 milliamps and 20 milliamps, say for example 12, it might open 50 to 60%. So this is how a normal control valve actuator works. So this is an example. If you use of a graphics, okay, where the double supply double extract fan, here we have a cooling coil. See here in the return line we have the control valve. So as we told earlier, after getting the analog signals to the DDC controller or to the PLCs, then we will map those tag values to the SCADA, so that Even after scaling, we used to give the values to the SCADA so that we can see the values in the SCADA. This is an example of a single supply double extract type, double supply single extract type, single supply single extract type. So see here, this is the chill water plant graphics. See here, we have a valve 1, 2, 3, 4, 5. At 5 different locations we are using this control valves, and even for after the heat exchangers also we have the control valves. All these valves we are operating with the help of the valve actuators. Okay. So now, as a BMS point of view, what are the things that you should know? So simple, as I told earlier, it is going to be an analog input signal and analog output signal. It can be 0 to 10 volt or it can be 4 to 20 milliamps. Okay, so if you are going for a chill water two-way control valve, okay, so the command, if you are going to give a control signal, it can be an analog output from the PLC. So that is why the PQW address is there. It can be from 0 to 10 volt DC. And if you, and also you are going to take a feedback from the valve actuator. Okay, what is its exact position? For that, you need to connect that into the analog input module. Okay. Thank you. Please subscribe and press the bell icon. If you want to know more and learn more, you can contact us. We had provided the contact details in it. Okay. We are providing design, installation, testing and commissioning, consultancy supports for even trainings. Okay, for the automation projects. Okay, it can be a building automation, it can be a automation inside the metro, it can be automation inside the mall, or it can be a process automation or industrial automation. You can contact us. So we have provided the contact details in it. And if you feel you need training for your reputed institutions, diploma college, engineering diploma colleges or engineering colleges, if you want a training, if you want your student to get trained on these things, you can contact us, because this session is are going to be very useful if you are going to work in a GCC, okay, where you're going for automation projects. In such places, it is going to be very useful. Even for the process industry also, this are going to be a basic foundations. So if you want to know more and learn more, you can contact us. And we are also providing design, installation, testing and commissioning supports for on-grid, off-grid and hybrid applications. Thank you so much.